Imagine you have 3 houses on a sheet of paper, and 3 utility sources: water, electricity, and gas. Your goal is to connect each house to all 3 utilities, making 9 lines in total. However, there is one strict rule. No 2 lines are allowed to cross or overlap. If you try to do this manually, you will always get stuck on the very last line. You cannot connect the last house to the final utility without crossing at least one of the existing lines. In graph theory, this puzzle is represented by the complete bipartite graph K33. The question is whether this graph is planar, meaning it can be drawn on a flat surface without intersecting edges. The legendary mathematician Leonhard Euler proved that solving this puzzle on flat paper is mathematically impossible, using his famous formula for planar graphs: V minus E plus F equals 2. Here, V is the number of vertices, which is 6. E is the number of edges, which is 9. And F is the number of faces, or enclosed regions, created by the drawing. If a planar drawing exists, we can solve for F, substituting our values. 6 minus 9 plus F equals 2. This tells us that any valid, non-crossing drawing must partition the plane into exactly 5 enclosed faces. Since this is a bipartite graph, there are no direct connections between houses, or between utilities. This means any closed loop, or cycle, must have at least 4 steps. Therefore, every face must be bounded by at least 4 edges. Since each edge is shared by at least 2 faces, we get the fundamental inequality. 2 times E must be greater than or equal to 4 times F. Now, let's substitute our known values: 2 times 9, and 4 times 5. This leaves us with the statement: 18 is greater than or equal to 20. This is a clear mathematical contradiction. Since 18 is not greater than 20, it is logically impossible to connect the 3 utilities on a flat sheet of paper without crossing lines.